Hi, scientists. This week, we're going to continue to learn all about sound. And we're going to explore how sound works in musical instruments. We're going to watch some videos, read some books, do some experiments about sound, and you might even get to make your own musical instrument. Today, I want to read a book called Amazing Sound. Some of the information in this book will be a review from last week, but some of the information will be new too. Let's get started. Amazing Sound. This book is written by Sally Hewitt. This boy here is playing the drums. Maybe you can play the drums or you'll get to make your own drum. Amazing Sound. The moon is quiet and still. There is no air to make sounds and no wind to blow the dust on the moon's surface. Sound is made by moving air, so without air, there is no sound. Earth is surrounded by air. It is a noisy, busy place. So here on Earth, we have air everywhere, so we have sound everywhere. But what about in space if there's no air? Is there no sound? Traffic, rain, hitting umbrellas, and people talking are all familiar sounds. Your turn. Listen. What can you hear? Do you know what is making the sounds you hear? Last week, maybe you went on a listening scavenger hunt. You went outside and listened. I wonder what you heard. Vibrations. A hummingbird beats its wings so fast that they look like a blur. The wings move the air and we hear it as a hum. People hear sounds when moving air goes into their ears. When a drum is hit, the air around it vibrates or moves very fast. The moving air makes the sound. So we know that sound moves in waves or vibrations, and those vibrations are moving back and forth very, very fast. When a drummer plays a beat, vibrating air goes into our ears as a sound. Your turn. Put your hand on the television while it is on. Can you feel the vibrations? Maybe that's something you can try at home. Ears. A herd of elephants walks through the savannah. Their enormous ears listen for danger. Ears are shaped so they can pick up sounds. People and animals hear with their ears. Our ears help us hear sounds all around us. We use our ears to hear our friends talk. Your turn. Cup your hand around your ear to make it bigger. Can you hear better now? That's something we tried last week. Do you remember? We put our hand around our ear. Can you hear better? Give it a try. Loud and quiet. Loud sounds can damage your ears. Workers at airports and Air Force bases wear equipment that protects their ears from the sounds of jets. The eardrum and tiny bones inside your ears vibrate when sound goes into your ears. Quiet sounds are made by small vibrations in the air, and loud sounds are made by large vibrations. Mice make quiet sounds. Your turn. Clap loudly. Clap quietly. What do you do to make a loud or quiet clap? Let's give that a try. Can you make a loud clap? Can you make a quiet clap? What do you do to make different sounds? Low and high. A bear's low growl rumbles through the forest. It scatters deer and scared birds out of the trees. People and animals make sounds with the voice boxes in their throats. High sounds are made by fast vibrations. Low sounds are made by slow vibrations. A small bird makes a high sound when it sings. Scientists, you're going to have a chance to do an experiment with cups and water to make a xylophone. You can try out making high sounds and low sounds. Big and small. Enormous waves roll onto a beach. They break onto the sand with loud, crashing sounds. When waves are big, loud sounds are made. When waves are small, they make quiet sounds. You have to listen carefully to hear them. When the sea is calm and quiet, it only moves a little. Scientists, have you ever been to the beach? Imagine those big waves, how loud they are. Or imagine a lake or an ocean with small waves, how quiet it would be. It's the same with sound waves. Big sound waves make big sounds. Little sound waves make little sounds. Traveling sound. In a thunderstorm, flashes of lightning split the sky. A few seconds later, thunder crashes with a loud bang. Light travels faster than sound does, so lightning is seen before the bang of thunder is heard. Scientists, have you ever been in a thunder and lightning storm? You see the lightning before you hear it. Light travels faster than sound travels. Sound needs something to travel through. It travels through air, water, the ground, and even walls. Scientists, do you remember when we looked at that beginning page from space? In space, if there's no air or water, then there can be no sound. Sound has to travel through something. Have you ever heard sound underwater? Or through a solid thing like a door? Sound has to travel through something. The sound of whales singing to each other travels through the water. Your turn. Listen. What have the sounds that you hear traveled through to reach your ears? What about me reading this book? What have those sounds had to travel through? Near and far, a track rumbles along the highway. Its engine sounds louder as it gets closer. The closer you are to a noise, the louder it sounds. Sound seems quieter as it travels through the air. A noise coming from far away sounds quiet. As an airplane goes up in the sky, it seems quieter. Your turn. Ask a friend to talk to you. Move away gradually. That means slowly. Hear how his or her voice becomes quieter. You can try that, scientists. Talk to someone really close. Talk to someone far away. Does it change? Does it get louder or quieter? Echoes. Bats dart through the night sky, catching insects to eat. They use their ears to find insects in the dark. Scientists, you may have heard of something called echolocation. That's how bats use their sense of sound to actually see. They use the echo that things make to know where they are or what's in front of them. The sound of a bat's squeak hits an insect and bounces back into the bat's ears as an echo. The bat then knows where the insect is to catch it. That's so cool. When you shout in a cave, your voice bounces off the walls and you hear an echo. Have you ever heard your own echo? Your turn. Bounce a ball off a wall to see how an echo works. Your voice bounces off the wall just like a ball. Cool. Music. Blow, bang, pluck, and struck instruments to make sounds. These sounds make music. Air tubes, strings, and drums and drum skins vibrate when instruments are played. Short strings play high notes, and longer strings play lower notes. Cello players press the strings with their fingers to make the strings shorter. Your turn. Make instruments. Put rice, beans, or pasta into containers with lids. Shake them and hear the different sounds. Scientists, that's one of our activities from this week. I'm going to show you a lot of different ways that you could make instruments, or you might come up with your own way to make an instrument. Sending sound. Your voice can travel to satellites in space and back to Earth, which lets you talk to someone far away. The sound of your voice is sent from a telephone to satellites on invisible radio waves. Your voice can travel from telephone to telephone along wires. Scientists, back when I was little, we only had telephones like this, telephones that were connected to a wire. And the sound waves would travel through that wire. And then maybe you've seen on the road, you've seen telephone poles with wires across, and the sound would actually travel through those wires. But that's not what we use. We use cell phones. So do you think cell phones send sounds along wires? Or do they send sounds along radio waves to satellites? What do you think? How do cell phones work? Scientists, I hope you enjoyed my book today. I hope you get to try out some of our sound experiments and maybe even make a musical instrument. If you do, share it with us.